Welcome all to this first video of Digital X Transform Education. My name is Mohammed Ashur and I'm going to be presenting to yourself today a session about data realm, the rules in the data realm, the data lifecycle, and my learning journey in the data world, alongside some recommendations. So, Digital X is an initiative by myself to give some more information to people about the new tools existing in the industry around us and how they could be implemented in construction alongside some applications, and how could we make the best use of these tools to make our life easier, to make the lines of work and deliver more in less time. This is Mohammed Ashur. I do have a Bachelor in Civil Engineering, and I've completed my Masters in Commercial Management about 5 years ago. I've undertaken a couple of years ago a data analytics apprenticeship, and I do have about 7 years in construction industry. I'm an honourable member of the Royal Institute of Chartered Surveyors, and I am also a member in the British Computer Society. So the agenda for this session is going to be composed of 4 parts. The first part is going to be digital intelligence realm. The second part is going to be dedicated to the rules in the data world. The third part is going to be discussing the different steps or stages in the life cycle of the data. And the last section or last part is going to be dedicated to the learning journey in the data world, alongside some recommendations. So, part 1, digital intelligence realm. What do we mean by that? So, this part is dedicated to make us understand how different people coming from different industries may use the tools to deal with the data in their fields and develop some sort of meaningful analysis. So, as you can see here, there are a lot of them domains who could use the tools available in the data industry to dig deeper into the available data, transform them into meaningful information, and then undertake proactive analysis. Project managers, they do have a lot of use cases for them, including but not limited to program management, tracking performance on sites, scrutiny, especially in when claims are being submitted, also parsing PDFs and documents and saving data from these PDFs into databases. Cost consultants, definitely tracking costs is one of the most important things that cost consultants can do. Also, challenging different parties when claims are being submitted, having an understanding on the patterns of costs, inflation analysis, and maybe cost predictions. Human resources could also use tools in the data industry to automate their line of work and take care of the tedious paperwork that they have to undertake for a lot of them processes, including but not limited to hiring new people, interviews, documenting subtitles for these interviews, understanding the pattern of employees, or tracking the progress in different companies. Accountants also can use the data to understand the financial stance of the companies and help improve the actual financials within a certain firm. So some of the digital intelligence ideas, as we said before, cost consultants could do cost benchmarking and prediction. So if they do have a humongous amount of activities, they could do benchmarking, understanding the yardstick for the costs per primary quantity and unit of measurement of every specific activity, and tracking the costs as well. Prediction could be undertaken when you have a huge database that you have a model trained to, and then you could predict how much a certain activity is going to cost based on a variety of parameters. You could have project size, project location, quantity, and different other parameters. Program benchmarking, that could be quite useful for project managers. They could undertake the same exact task but with respect to time intelligence. So they could benchmark each and every single activity depending on the resources, the number of gangers, the number of labour involved in that activity, the type or the kind of equipment used, the location itself, depending also on the construction sequence and the likes. HR, they could be using digital intelligence for automated onboarding and taking care of the tedious paperwork. Also, one of the good things that I've seen in the industry is that PPUs or HR professionals, they tend to use Power Automate, Microsoft Power Automate, to send automated emails to employees on a sort of basis to undertake a specific task, and that could be done easily in a matter of minutes instead of sending these emails manually. Balance sheets also, that is quite related to accountants. They could parse PDFs and text in balance sheets and derive some meaningful information from that data, and they could build some sort of patterns and analyze these patterns for predictive analysis. Carbon benchmarking. So nowadays we have humongous amount of understanding and caring about sustainability and the likes. So sustainability has 3 or 4 pillars depending on different schools of thoughts. So environment, economy, and society. So the environment is one of the largest parts and pillars of sustainability. So different companies nowadays, in order to meet the targets for 2030 and 2050 and the different agreements for the Clean Air Act and different agreements for pollution and the likes, they have to track the carbon emissions from different projects, and they have to understand how each and every single project is producing carbon emissions in order to meet these targets. Last but not least is inflation patterns and prediction. So there are a variety of websites that provide inflation indices. One of them websites, which is developed by the Royal Institution of Chartered Surveyors, is the Building Cost Information Service, or the BCIS. This website contains a wide variety of indices, including but not limited to tender price index, resources cost index, price adjustment formula indices, construction cost indices, and also there are some new indices called NERA, which are dependent on the price adjustment formula indices, or PAFI. The understanding on the year-on-year, month-on-month, or quarter-on-quarter change of each and every single index can allow us to understand the pattern of change of these indices, and hopefully we could do some sort of meaningful prediction in the future. And there are a wide variety of pieces of technology using Excel or relying on machine learning models on Python, which could really or surely help us do the predictive analysis for the inflation. Now moving on to part 2, the rules in the data world. So there are different rules that we can find around ourselves in the data world. There is a massive misconception that data analysts, they do everything in the data world. However, nowadays there is a wide variety of roles who are having different responsibilities and skill set that is required from them. So let's explore together different roles. So we could find data analysts, data scientists, data engineers, business intelligence analysts, and database administrators. And each and every single one of them, they have their own skill set, required skill set, and corresponding responsibilities. So for data analysts, they specialize more in collecting the data, cleansing the data, validation, and then they rely on visualizations on different pieces of software such as QLIC, Tableau, or Power BI. They have to have also some pieces of software that they know by heart, such as Microsoft Excel, Power Query, Power Pivot. Some data analysts, they try to excel by learning Power Automate to automate the workflow. Also, some of them, they rely on having understanding or sheer understanding on Power Apps to create applications in a low coding environment. and that is reliant on the data structure and data policy in the company. If the company is reliant on Microsoft, then Microsoft Power Platform is going to be your best friend. Otherwise, different options are available. Some data analysts, they deal with millions of rows of data. That's why they might rely on a standard query language or SQL. Other data analysts, they rely on Azure Cloud Computing and the corresponding Dataverse. Again, that is dependent on the data architecture and organizational data structure in each and every single firm. Data scientists, they might have some areas of overlap with data analysts. You can visualize that as a Venn diagram when you have two circles intersecting in a specific part. So data scientists, they have to have understanding on how data is collected, how data is cleansed, but also they have to have sheer understanding on programming techniques in order to crack on with machine learning models, artificial intelligence models, and they have to have a very sheer understanding of mathematics in order to be able to deal with matrices, vectors, and predictive analysis. The skill set can extend to Python, programming language, R as well. However, Python is much more used in the AI realm. They have also to have understanding on different methods of regression and different pre-made models of regression. Data engineers, they work closely with data analysts and data scientists to build and maintain the data infrastructure within each and every single firm. This could be understanding how to do the folder structure on SharePoint, for instance. If the company is reliant heavily on the Microsoft Power Platform, then SharePoint is going to be the main repository for the data. So identifying where the data sit, what is the folder naming convention, what is the leveling of the folders to identify which folder is the parent folder and which folder is a child folder, which is going to impact the metadata. So that's going to be determined by the data engineer. The data engineers, they have to have sheer understanding on the data lifecycle. A very useful document that you could have a read on is the UK Data Quality Framework. It's a website. I can send you the link separately for that one. The data engineers, they have to have sheer understanding on database architecture to facilitate the workflow for data scientists as well. Nowadays, because the internet, we can't really do without internet, so cloud computing should be sheerly known by the data engineers as well. Business analysts, again, there's going to be an overlap between business analysts and data analysts. Business analysts, they tend to deliver business intelligence solutions, which could involve having visualizations on pieces of software like Tableau or Power BI, again, to show key performance indicators, create reports, analyze trends. Some firms, they rely on a business intelligence expert to showcase the work and convince the C-suite using PowerPoint, and having a data analyst in the background grinding through millions of rows of data, cleansing the data and the likes. Business intelligence analysts or experts, they have to have sheer knowledge on Power Query and Power Pivot, and definitely a means of visualizations such as Power BI. They might also need to have an understanding on databases such as SQL or Dataverse. Last but not the least, data administrators. They work closely with data engineers to maintain the databases that has already been built by data engineers, and also they maintain the data structure as well. They liaise usually with data analysts and data scientists to make sure that the data being used is compliant with the corresponding data laws or data compliance policies within the firm. They also have to have this understanding on SQL, Azure. Also, they have to know the data architecture within the firm, and they have to be proficient in the data compliance policies. Part 3, the data lifecycle. So there are a lot of definitions for the data lifecycle in different resources, However, for the purpose of this session, I'm going to focus on the UK Data Quality Framework definition of the data lifecycle. So, the data lifecycle is composed of 6 steps. First step is plan. What do we mean by plan? So plan, the business need to understand what are the requirements, who are the clients, and what pieces of software are available or required to be bought or licensed, depending on the projects. The next step is collect, acquire, and ingest. So when the business directors, they sit with the client, understand what the requirements are going to be, what projects are going to be delivered, and what are the key requirements and key performance indicators required by the client to be shown, they would understand what type of data is going to be collected, processed, and shared. And that allows the business owners to understand how they could draft a set of validation rules. The third step is going to be preparation of the data, storing it, and maintaining it. And again, I'm stating data, not information, because information is processed data. So that's going to be dependent on different organizations. So for argument's sake, here in the UK, a lot of construction industries, they rely on Microsoft Suite. So we're speaking about Excel, PowerPoint, Word, Outlook, Microsoft Power Platform. So here the case is going to be storing the data on SharePoint. However, different companies such as Cisco, they use Box and Smartsheets instead of SharePoint and Microsoft Suite. So the storing and maintaining of the data is going to be quite dependent on the data architecture and the organization data structure. So if the files are going to be in Excel, in Word, in PDF, and the likes. In this step, some questions about data quality are going to be raised, including but not limited to the consistency of the data, any ambiguity that could be found, timeliness of the data, and there are loads of other data quality issues that could appear and gaps as well. The fourth step is going to be the use and the process, and here begins the fun, because based on the validation rules that have been set before in the collection phase, and based on the data quality issues or questions that have been raised, now it's time to dig deeper into the data, understand the patterns, undertake cleansing, prepare the data, and then produce meaningful analysis. In a lot of cases, visualizations are a must, so this has to be done using visualization software such as Qlik, Power BI, or Tableau, or other pieces of software now available online. The fifth phase or step in the life cycle of the data is sharing and publishing. So that's going to be sharing and publishing information. At that point, quality assurance has to be the main key point raised, where other pairs of eyes, they have to review the past 3 or 4 processes to make sure that based on the business needs and based on the client requirements, that the data received have been analyzed and explored adequately to provide meaningful information for the client. Some clients, they would require the data to be masked in a way, whether by anonymization or pseudonymization. So for argument's sake, let's take an example. If you have data about London Bridge, and imagine that the City of London, they don't want the name London Bridge to be apparent on any database or any report. So there are 2 ways for it. Basically, you could replace London Bridge by gibberish characters, or you could replace London Bridge by Bridge 1, for argument's sake, or Bridge A. And then the client would have a deciphering layer which could translate between normal English and gibberish English, if that makes sense. This phase is also, there's a step in this phase which is quite important, which is documentation of the solutions produced or provided to the client. The documentation has to be containing some background information about the solution itself, in terms of the use of it and why was it created in the first place. Also, the main features of the solution, data sources that have been used, processing steps for the data sources, what were the data quality issues and gaps, how these would have been solved, and also what pieces of software have been used, and last but not the least, what is the platform on which the meaningful information and meaningful analysis have been shared. That could give the client a peace of mind about how to run the solution after being handed over by the consultant. Archiving or destroying of the solution or the information. So that's going to be dependent on the use case. So for argument's sake, if a consultant has been working on a humongous piece of work for a client, then it makes sense that this piece of work is going to be destroyed after a short time. But if a company is dealing with or creating a solution for its own use, then archiving might be the best option. And also, if the solution is quite dependent on personal information, then depending on every country and depending on every organization, there is a data policy in every country and organization. RICS, they do give, I think, about 7 years before destroying, permanently deleting any personal information of third parties. So yeah, it's quite dependent on different businesses, different countries, and different practices. The last part of today's session is going to be part 4, which is the learning journey in the data analytics or the data realm. I'm going to speak about my learning journey and some recommendations in that sense. So my learning journey, or the map of my learning journey, has started with Microsoft Excel. I've had very sheer understanding on Microsoft Excel and lots of knowledge about it. I would suggest people focus on the text related functions and the spill functions. So the text related functions could be like the mid, left, right, text before, text after, text, value, and length. Filter and sort are also quite strong formulae. All these functions we can discuss them later on in other videos. Spill functions, that is a new technique in Excel 2016 and later, where instead of having the old array functions where you have to press Ctrl-Shift-Enter, you can now specify a certain range. So for argument's sake, if you want to refer to cell A1 multiplied by B1 is going to be equal in C1, you could refer to a whole range multiplied by a whole range, and that's going to spill the formula. So for argument's sake, it could be cell A1 to A10 multiplied by B1 to B10, and then one form is going to be written, and that's going to decrease massively the amount of storage in the RAM and in the memory in general. The second thing that people can learn in the data analytics realm is Power Query. So if you do have Excel sheets or different files having some sort of like a standardized formats, they could be imported in Power Query, and loads of cleansing and preparation could be done in Power Query. So some of the aspects that I have massively benefited from in Power Query is the merge function. When you have different tables, you can merge together or append lots of lists one beneath one another. The language used in Power Query is called the M language, so it might be useful to have an understanding on the basics of the M language. There are loads of Power Query functions which you can read about in the Microsoft documentation. They can be used quite a lot in the custom columns when adding custom columns. One of the strongest functionalities in Power Query is pivoting and unpivoting the columns. So if you have lots of columns in a horizontal format and you want to put them or transform them into a vertical format, which is the only way queries work, you can use the option of unpivoting the columns. If you have lots of columns in a vertical format and you want to put them in a horizontal format, you can use the pivot options. That is quite strong, and we can discover that later in other videos. Power pivot. Power pivot is a very strong piece of technology developed by Microsoft in 2010, and it was the basis upon which Power BI was created. So Power BI it takes into account Power Query and basically builds on Power Pivot. So Power Pivot is quite worthy to learn DAX functions, which are the functions used in Power Pivot, which are equivalent to the formulas used in Excel. Power Pivot allows understanding the data modeling, which is the relationships between different tables, the one-to-one relationships, one-to-many relationships. Unfortunately, the many-to-many relationships are not available in Power Pivot, they're just available in Power BI. Power Pivot, or the pivot tables, they could allow developing pivot charts where you can filter the chart based on different criteria or slices in Power Pivot. The next piece of the puzzle is Power BI, one of the best and most known data visualization software developed by Microsoft. The learner has to have a decent understanding on DAX functions, which they could already learn from Power Pivot, but also Power BI, it has a lot of new updates in the DAX functions. Data modeling could be quite helpful as well because it is reliant on data modeling. Power BI provides a pre-created list of visuals, and custom visuals can be downloaded from the Microsoft Store. Also, there could be some bespoke visuals developed by Python and R language. People learning Power BI, they have to have now sheer knowledge on how to make the dashboard quite intuitive in a way that is resembling applications, also taking into account the percentage of matching between different colors. One of the very strong aspects that has to be focused on in Power BI is the bookmarks, how to create bookmarks and how to link these bookmarks to different images so that you could create the button effect as if it's an application. Power BI also provides very sheer support to a variety of data sources. However, the data sources themselves, they have to be, that is going to be dependent on the licensing provided by the firm itself. Power Apps, Microsoft Power Apps. Microsoft, they have provided a low coding environment where you could create a whole application using Power Apps. They have three main types of Power Apps. The Canvas, where you could create an application from scratch, model driven. They are reliant on prefabricated models, and Power Pages, which is basically building websites without having to code a lot. The Canvas apps, they can be quite powerful if integrated with Power BI. You could insert galleries, you could insert buttons, and you have to have some decent understanding on the formulas used in Power Apps, such as navigate, and you have to also to understand the different properties within each and every single element that you put in the app itself. Power Apps, they rely on a variety of data sources where you can link the data to, including Dataverse, including SQL servers, OneDrive for Business, and lots of other connectors. Again, that is going to be reliant on the license available within your firm, whether it's a basic license or a pro license or a premium license. The next stop is Microsoft Power Automate. Microsoft Power Automate, it is quite resembling the macros on Excel, where you put in some sort of like a logic and then the flow can create things for you. There is a wide variety of flows available to be used, prefabricated or from scratch. That's completely up to you. Again, that's quite reliant on the level of licensing that you have within your organization. One of the decent things about Power Automate is that they have added an AI builder with lots of functionalities, including parsing parsing PDF files, or doing sentiment analysis and predictive analysis. Power Automate has a dedicated version for the desktop, and this dedicated version for the desktop has a variety of connectors, has a variety of flows as well. One of the best things to do with Power Automate desktop is that it could automate tasks that you do on your computer in a way that resembles the macros in Excel. So for argument's sake, it could be used for web scraping or copying sheets from one folder to another, or putting in some text in Word files. You could use it massively to automate massive amounts of tedious tasks that can be done on a turbo basis. So all of them tools that we have discussed today, or in this slide, they could be quite related to a data analyst. The next one is Python. So Python, it could be used by data analysts. It could be used by data scientists. So I myself use a lot of pandas and NumPy to collate, cleanse, and put the data in a good form to be analyzed and to be visualized as well. If you're going to take it a step further for machine learning and AI and to be a data scientist, then you have to learn scikit-learn package. And nowadays we're not going to be creating the wheel from scratch. There is a lot of prefabricated and pre-made models for machine learning and AI. Myself, I've done some sentimental analysis using a wide variety of models such as Veda Sentiment, Roberta, BERT, Google Flan T5, and TextBlob. Generative large language models are now a massive craze in the industry, and in order to be able to deal with them, you have to have sheer knowledge of Python, how the loops work, how the import from repositories online work, and the likes. And that could be discussed in future sessions.